Welcome back to the Deep Dive, where we help you cut through all the noise and get right to the knowledge you need.
Today we are diving into something that's been, for years, kind of the holy grail of electric vehicle tech.
The solid state battery, you've got these huge global car companies in Detroit, in Germany, in Japan, all promising it's just 5 years away.
Always 5 years away. But as it turns out, the first company to actually get a production vehicle with a solid-state battery on the road isn't a Ford or a Toyota.
No, it's a Finnish motorcycle company, Verge Motorcycles. They've kind of leapfrogged the big players and are putting this tech, directly out of the lab and into their TS Pro model.
And deliveries are set to start within months. I mean, this is a really big moment. This is lab tech hitting public roads.
So for our deep dive mission today, we're going to unpack this. We've got the press coverage from places like Highways Today. We've got the direct claims from Verge themselves.
And crucially, we have the online scrutiny. We found a great Reddit thread where people are really digging into the claims, which is, exactly what we need for a balanced view.
Right, because our goal here is for you to really understand why this matters. We're talking huge shifts in safety, charging, how long these things last.
But also to temper that with a look at the real-world limits.
Yeah.
What does that range number actually mean on a highway? And, of course, the price tag.
Okay, so let's start at the beginning. What exactly makes a solid-state battery, or SSB, such a fundamental leap over the lithium-ion batteries in almost every EV today?
It's fascinating because the core change is structurally very simple, but its effects are just profound.
Okay.
Your conventional EV battery uses a liquid or sometimes a gel electrolyte. That's the medium that moves the lithium ions back and forth.
And that liquid is the problem, right? It's sensitive to temperature, it degrades.
And it's flammable. That's the big one. It's the primary reason you hear about battery fires and this thing called thermal runaway.
Can you just quickly define thermal runaway? It's a term we hear a lot.
Yeah, of course. It's basically a chain reaction. One battery cell overheats for some reason, and that heat triggers the cell next to it to overheat and so on. It's a dangerous, self-sustaining process.
A domino effect.
Exactly. A very hot, very dangerous domino effect. Solid-state batteries, they just replace that flammable liquid with a solid material. It could be a ceramic, a polymer.
So a solid material that doesn't ignite.
Precisely. And that one change just transforms the user experience. First, as you said, safety. The cells are way more stable. The sources say they effectively do not catch fire. The risk of thermal runaway is, it's almost eliminated.
But it's the performance gains that I think will really grab people.
Oh, absolutely. The first thing is energy density. Because the solid electrolyte is so much more stable and compact, you can pack more energy into the same space.
More range from the same size battery, or a lighter battery for the same range.
Exactly. And the second thing is charging speed. That's a huge pain point.
It's the #1 anxiety for a lot of potential buyers.
Well, the solid structure can handle much, much higher charging speeds without being damaged. We'll get to the actual numbers in a bit, but it completely changes the math for a road trip.
And the last piece is longevity. People worry about having to replace a $10,000 battery pack after 8 years.
And they should. With SSBs, they can tolerate way more charge cycles before they start to degrade. So you're looking at a battery that's genuinely designed to last the entire lifetime of the vehicle.
That is a game changer for long-term ownership costs.
And we should also mention, Verge is already known for this kind of thing. They're the ones who came out with that hubless in-wheel electric motor.
Right, which was already a big deal. It got rid of the chain, the belt, all of it. So they have a history of thinking differently.
They do. And this latest move is, well, it's their biggest yet. Verge worked with a technology partner, Donut Lab, to get this ready for the road.
And the CEO, Tuomo Litameki, he didn't mince words. He called it a historic breakthrough shaking up the entire automotive industry.
That is a bold, bold claim. So we have to ask, what's under the hood, so to speak, to back that up?
What are the engineering details?
Well, they've paired the new battery with their next-gen motor, the Donut 2.0. It's 50% lighter than the last one.
50%.
50. And it still puts out a massive 1,000 Newton meters of torque.
Wow. Okay, so for a bike, that translates to some serious acceleration.
Very serious. 0 to 62 miles per hour in just 3.5 seconds. This thing is competing with high-end superbikes. They unveiled the whole production-ready platform at the big EICMA show in Milan.
The fact they could integrate such a new battery technology so quickly, That says a lot about their design.
It does. They built the bike on a modular platform from day one. That architecture means they can slot in a breakthrough like SSB without a 5-year redesign process like a traditional car maker. They're built to be agile.
So let's get to what you can actually buy. There are two options available for customers soon.
Correct. You have the standard pack, which is a 20 kilowatt hour battery,
Hmm.
and then there's the extended range pack, which is a huge 33 kilowatt hour battery.
33 kilowatt hours that's enormous for a motorcycle.
Verge calls it the biggest of its kind by a long way. And that size, combined with the new charging speeds, that's where things get really interesting.
Right. This is where we really start to tackle those core EV anxieties we talked about. How long do I wait and how far can I actually go?
And for most people, waiting 30 or 40 minutes at a charger is still a major hurdle. Verge is claiming this tech pretty much solves that.
Okay, so let's break down the charging speeds for the two packs because they really are pretty wild compared to what's up there now.
They are. The standard 20 kilowatt pack charges at 100 kilowatts. That adds about 200 kilometers or 124 miles of range in just 10 minutes.
10 minutes. That's a coffee break.
It is. But the extended 33 kilowatt pack, that one ramps up to 200 kilowatt charging. It can add 300 kilometers, that's about 186 miles range, in under 10 minutes.
That's incredible. And this is where that Reddit thread gave us a fantastic bit of context. The user did the math and figured out that pushing 200 kilowatts into a 33 kilowatt hour pack means it's charging at a maximum rate of 6C.
Okay, 6C. For those of us who don't live and breathe battery specs, what does that number actually mean in the real world?
It's basically a measure of how fast you can charge a battery relative to its size. So a 1C rate means you could fully charge it in 1 hour. 6C means you could theoretically charge it 6 times in 1 hour.
That is a massive number.
It's huge. That's nearly double the rate of some of the best performing electric cars out there, like a Porsche Taycan or Lucid Gravity. They're usually in the 2C to 3C range. So this really shows you how high performance this SSB implementation is.
And the implication for you sitting in your electric car is pretty clear. If a motorcycle can do this today, it means the path for regular cars to get to 350 plus kilowatt charging is now much, much shorter.
The whole benchmark has been moved.
Yeah.
So, okay, let's talk about the other big number range.
The headline grabber.
What are the maximum stated ranges for these two packs?
For the standard range, they're claiming up to 350 kilometers, which is 217 miles. And for the extended range, the big number is up to 600 kilometers.
About 370 miles.
So roughly 370 miles, yes.
That's a very compelling number, but I actually think the longevity part might be even more important for a buyer.
I completely agree. The idea that this battery pack is designed to last the entire lifetime of the motorcycle. That tackles the biggest financial fear of EV ownership head on.
No more worrying about that massive replacement cost down the line.
Exactly. And crucially, Verge confirmed that adding this cutting-edge tech does not increase the retail price of the bike compared to their older models. So you get a massive technological upgrade for essentially the same price.
Okay, so a 370-mile range. That's the headline that gets all the attention, and it's also the one that gets the most scrutiny. So we have to pump the brakes a bit and look at the critical perspective.
We do. We have to separate the marketing claim from the real-world experience. And again, the Reddit discussion was invaluable here.
So what's the reality check on that 370-mile number?
Well, a user found the fine print on Verge's own website. Under more realistic test conditions, a 165-pound rider going a steady 56 miles per hour, the range was 196 miles.
Okay, so that's a lot closer to reality, but still a long way from 370.
Right, so you can pretty much assume that 370-mile figure comes from very low-speed, gentle city riding, maybe 30 miles per hour, no hard acceleration, not practical for a long trip.
And if you apply the standard practice for preserving battery health, keeping it between 10% and 80% charge, and you're traveling at highway speeds.
Your realistic, usable range between stops might be, 80 to 100 minutes of riding?
So it's not the cross-country marathon machine the headline might suggest?
It's not. It's more suited for fantastic day trips or weekend touring where you stop for coffee every hour and a half. But the revolutionary part is that your stop is just a coffee break. 10 minutes, and you're good to go.
It's a different way of thinking about touring. But we can't ignore the other major hurdle here, what the source is called wallet anxiety.
Yeah, this is not a cheap motorcycle. It's firmly in the high-end, early adopter category.
What are the prices?
The standard 20 kilowatt model starts at $30,000. The extended 33 kilowatt art version is $35,000.
$35,000.
Yeah.
Okay, so that's comparable to other premium electric bikes like the Live Wire, but
Yeah,
I mean, it's a huge investment that puts it out of reach for most
for
riders.
sure. We're talking about a niche market here. But I think the verdict, when you weigh it all, is that this is both hype and reality.
How so?
The hype is the idea that you can ride for 370 miles straight on the freeway. That's not happening. But the reality, the real genuine achievement, is that they delivered the core SSB tech in a road-legal product that you can buy. They proved it can be done right now, and that's the real story.
Which brings us to the most important question for probably most of our listeners who drive cars, not bikes. What does this mean for the bigger picture?
This is the key takeaway. Donut Lab, the tech partner here, has been very clear that the Verge TS Pro is just, and I'm quoting here, an excellent first example.
So this was never just about one motorcycle.
Not at all. It's a platform. Their CTO, Vil Pipipo, stated that the battery tech can be used in all types of vehicles, from motorcycles and passenger cars to trucks, robotics, and stationary energy storage.
So it's completely scalable. Given that high price point, though, where do you think we'll see it pop up next?
Well, I'd expect it to appear first where the cost can be absorbed and the benefits are most critical. So think high-end performance cars, hypercars, where energy density and low weight are everything.
Or maybe even industrial applications.
Absolutely. Specialized robotics, heavy-duty delivery vehicles, places where you need extreme durability and super fast turnaround times. The sustainability angle is also really important.
Right, the supply chain issues with materials like cobalt.
Exactly. SSB manufacturing can often use more globally abundant materials. That reduces the kind of geopolitical risk and supply chain volatility that we see with current batteries. It just makes scaling up much more stable.
So Verge has really put the entire EV industry on notice.
They've raised the bar overnight. Every single manufacturer now has to contend with a new customer expectation. Safer batteries, faster charging, and lifetime durability are no longer theoretical goals for some time in the future.
A small company in Finland just delivered it.
They did. And for any city planners or policymakers listening to this, this should be a major signal.
Why them specifically?
Because if a bike can pull 200 kilowatts from a charger today, you have to urgently prepare your grid for when cars and trucks start demanding 350, 400, 500 kilowatts. The infrastructure needs to be ready for that kind of massive, rapid energy transfer.
That's a really good point. The tech is moving faster than the infrastructure planning.
Much faster.
Okay, so to wrap this all up, Verge motorcycles didn't just tweak a bike. They fundamentally transformed the battery inside it. They proved solid state is viable today.
That shift from a flammable liquid to a stable solid is the whole story. It's a breakthrough that touches on safety, on lifespan, and on the simple convenience for every future EV owner.
The Verge TS Pro itself might be a niche, expensive product for now, but the fact that the tech is real, that it's been validated in a vehicle you can actually buy, that's what's going to ripple through the entire industry.
It is. The genie is out of the bottle now.
So here's a final thought for you to chew on, something that builds on this idea of durability. Given that this battery is engineered to last the lifetime of the vehicle, and the tech is scalable to stationary energy storage for, your home, how does that change the economics of things like residential solar? If your home battery is suddenly guaranteed to last for 30 years without any real degradation, it completely changes the long-term cost of adopting renewable energy. It could make it far cheaper and more resilient than any of our current models predict.
That's a great question to end on. Thanks for diving deep with us.
Until next time.